What's up, guys? Welcome to session 14, the final session for Linux Bash Scripting Intermediate Level. As always, I'm your instructor, Kevin Downs. Today we're going to be briefly talking about compound commands. Last session, we went over writing functions, returning value from functions, returning string output, local and global variables, defining functions, and case shell autoload functions. This course, we're going to be talking about pipelines, command lists, and/or lists, background jobs, command grouping, and input-output redirection. As another note, all these topics are covered in our previous courses, such as Intro to Bash Scripting. So if you need a little bit more in-depth discussion, be sure to take those courses or follow the links at the end of this PowerPoint for some private tutoring sessions. But let's go ahead and get started with pipelines. So a sequence of one or more commands separated by a pipe, which is this vertical bar, which is above the enter key or return key on a keyboard. Each command in the pipeline, except possibly the last command, is run as a separate process. However, the standard output of each command that is connected by a pipe becomes the standard input of the next command in the sequence. If a list is enclosed with parentheses, it is carried out as a simple command that operates in a separate subshell. If the reserved word exclamation point does not precede the pipeline, the exit status will be the exit status of the last command specified in the pipeline. Otherwise, the exit status is the logical not of the exit status of the last command. In other words, if the last command returns 0, the exit status will be 1. If the last command returns greater than 0, the exit status will be 0. The format for a pipeline is as follows. So optional exclamation point command 1, pipe, and then command 2. So guys, basically all it's saying is with pipes, the first command you run runs the standard out of that, gets piped into the standard input of the next command after that pipe. Okay? Here we have a list of some common commands. pwd, which is print working directory, cd, change directory, remove, which removes files, cp, which will copy a file. Okay? You'll actually get a duplicate of your file. Move, which does two things. One, it renames a file, and two, it changes the inode. So it actually changes the location of the file on the system. We have ll, which is a long listing command, or ls-l, which will also do a long listing command. This shows permissions and extra information about your files. We have df, which is a disk-free command, shows you how much space you have free on your disk. And you have du command, which shows you disk usage. This actually shows you what files are using the space on your disk. And guys, here is a cheat sheet for commands. A little hard to see here, but if you do a Google search for Linux command cheat sheet, there's tons of different cheat sheets out here. I guarantee you'll see this one among many others. Let's go ahead and talk about and or lists. So we have and as well as or list. So and is used to, so this is what and looks like, two ampersand symbols. This is used to chain commands together, such that the next command is run if and only if the preceding command exited without errors, or more accurately, exits return code of 1. So what that means is that I can run one command, I put this double ampersand symbol, and a second command. So if that first command runs successfully without errors, then the second command is going to run. So we have an ls-d here, which lists directories with the /. We have ls-F, which adds one character to entries. We have ls-I, which lists files, inodes, index number. And then we also have ls-L, which lists long format. Okay? Let's go ahead and talk about background jobs. So the shell normally indicates that the job has been stopped and then displays a shell prompt. You can then manipulate the state of this job, putting it in the background with the bg command to run other commands, and then eventually return the job to the foreground with the fg command. Guys, you can also use a single ampersand symbol, and this will also place jobs in the background. So for example, if I run a simple sleep command here, okay, so sleep 60, just so you know what it does. Oops. Sleep 60. So this puts my terminal to sleep. No matter what I type in, it's not going to show anything on my terminal because it's asleep. Okay. So what I can do is I can do a sleep 60 and then ampersand symbol, and there you go. It says, hey, that job is running. Here's the job number and what number job it is, first job, but it's running in the background. So if I do jobs, I can see, well, I have that job running there. Okay. And as we're about to see, to get out of that, we hit Control C or Z. So if you're running a job and want to do something else, use the Control-Z key sequence. This key sequence sends a stop signal to the current job. The shell normally indicates that the job has been stopped and then displays a shell prompt. You can then manipulate the state of this job, putting it in the background with the BG command, and run other commands, and then eventually return the job to the foreground with the FG command. The Control-Z key sequence takes effect immediately and is like an interrupt in that shell, and it discards pending output and unread inputs when you type the sequence. A job being run in the background stops if it tries to read from the terminal. Background jobs are normally allowed to produce output. You can disable this option by issuing the STTY to stop command. If you set this terminal option, then background jobs stop when they try to produce output or read input. Oops. Let's go and talk about command grouping. So using braces is valid only in the Bourne and Corn shells, guys. Okay, so we can't use the curly braces in any other shells. So when commands are grouped in braces, the shell executes them without creating a subshell. In the following example, the shell runs the date command, writing its output to the today.grp file, and then runs the who command, writing its output to today.grp. So we have the date and who command encapsulated in curly braces, and we have a semicolon in between them. And then we redirect the output of this to the today.group. Okay? So guys, what's important to know here is that the semicolon isn't piping anything into the next command. It's really treating this as two separate command lines. So date runs and gets redirected to today.group. Then who runs, and the output of that gets redirected to today.group. This is no different than me running the date command and redirecting it to today.group, and then on another command line, running the who command and redirecting it to today.group, okay? So that command is identical to me doing this. Okay? And then you'll notice that my sleep command just finished too. As you saw it show that there. And then who today.group. Okay? Then when I cat that file, you'll see I have both. I have Kevin, which is who, and the date. Okay? So I ran these two separately, but as we see in our example here, you can run them on one command line by using the semicolon and then encapsulating them in braces, and that way you can do it all in one go, which is super efficient. Let's go ahead and talk about input-output redirection. So shell redirection is a powerful way to change from where commands read input into where commands send output. It applies to every command run by a shell, so once you learn how it works on all the commands you can type. You can redirect the input of a command, and you can redirect the output of a command. The redirection could be to or from a file using the shell meta characters greater than or less than, as we just saw on our previous slide. Or it can be to or from a program using the shell meta character pipe, which we saw in a couple of slides ago. So pipe, greater than, and less than are ways to redirect your input and output. In summary, we talked about pipelines, command lists, and or lists, background jobs, command grouping, and input-output redirection. Guys, if you need more in-depth discussion on this or any other topics that you aren't sure about, be sure to click on these links and check out our weekly and monthly plans available for private tutoring sessions for system administrator management, as well as Linux and Bash scripting private tutoring sessions. Be sure to continue your education with some of the other courses we offer, such as Intro to Cybersecurity, Intro to Cloud Technology, learn how to manage Windows servers, Introduction to Database Design, learn SQL programming by examples, Introduction to NoSQL Database Design, learn Graph Database Design by examples. We also have some resources available for you, such as how Linux operating system memory management works, comprehensive review of Linux kernel operating system processes, comprehensive review of Linux file system architecture and management, what are mechanisms behind Linux kernel task management, how Linux kernel sources and functions work, and a comprehensive look at how Linux data structures work. Some classes to take immediately after this course would be Learn PHP Programming, Web Development with PHP and MySQL, Linux Management for System Admins, which is actually another course I'll be instructing, Intro to HTML and CSS, Intro to Python and Programming. Thank you so much for joining me, guys. I really enjoyed having you on this course. I hope you had a little bit better time of grasping how bash scripting works and kind of built upon some of the things we covered in our last course. And I'm looking forward to seeing you in our other courses on coding-bootcamps.com.